Let's do some math. So we are on 10.2, check on learning. So we just learned several different ways how to solve some exponential functions. So here we go. So this first one is using a chart. In my humble opinion, it doesn't make sense for us to solve first and then fill out a chart because the chart is meant to help us solve. So we're going to start with part B first. So, and again, we can just use our calculator for this. So we're going to pull that up, and we can enter this equation right here into our calculator. Y equals 130, let's move you up a little bit, parentheses, 1.03, parentheses, raised to the power of 2x. And we can graph it if we wanted to, but we actually want to look at our table. So we need to fill out these values for our table. I'm going to actually change my table set, and I'm going to have it ask for its x values so that I can make this a little bit easier. So I'm going to type in 10 here, and it's going to pop out the answer. It's using, again, this equation right here. So, whoops. So I'm just going to go down the list. And then we do 30. So that is the same thing that they got, more or less. My calculator is rounding to the nearest hundredth. We could change that if we wanted to. So then we're going to switch to increments of 5. So 30, we're looking for our function to equal 750. So we hit 30, we went over, so now we want to find that. So we found an upper bound, now we want to find that lower bound, see where it comes in. So 25, we tried that. 28, let's try that. Okay, we're not quite there yet. 29, and 30 is, let's see here, so 30 is 15 away, 29 is like 30 something away. So I think we're going to go with 30 when we round. So I'm just going to, let's see here. Oh no, my values got really small. I can't see them now. That's close enough. All right, so I'm just going to type those in here. 234.79, 424.06, so on and so forth. I'm not going to make you watch me type those in, but that's how you do it. We can check our answers for part B, and you'll see 234, 424, 569, 721. So the answers that we got as well. So we're good to go. So using that information, we made our table. We can then solve this part, enter the correct value in the box based on our chart down here. 30 was the closest. And since we're rounding to the nearest whole number, bam. Oh look, we can even check it. Y'all can check that one too, but we just looked at the values. So let's move on. Solve the equation algebraically. Love algebra. I just love algebra. Okay, here we go. So we've got 1, 3, 5, 0 with my awful handwriting. 100 1.4 times x. So we're going to do some basic algebra. We're going to get rid of that 100. So then that's going to be what? 13.5, right? I'm doing my... And so we're going to have 13.5 equals 1.4 to the power of x. So since we're already in decimals, I'm not really going to try to do the whole like matching bases thing. So we're going to use the definition of log to finish this up. So remember, that's going to be log base 1.4 of 13.5 equals x. Okay, so my calculator, we're pretending, can't do log base 1.5, so we're going to use the change base property of logarithms to change it to log base 10. So that property says that this is equal to, we're going to put this into a box so that it doesn't look like I'm dividing by, is equal to common log, or log base 10, of 13.5 on top, divided by log base 10, or common log, of log base, or of 1.4, I swear I could talk, equals x. So that is something that we can plug into our calculator. Boop. Oh, that's fun. No, that's not what I want. Calculator, come back. I summoned thee. Okay, so we just need our normal calculator function, and we're going to do common log of 13.5 divided by common log of 1.4 is equal to whatever that number says there. 7.735. And it says round to the nearest whole number. 7.7 will round to 8. Algebra. I love it. Solve the equation either graphically or algebraically. Round to the nearest whole number. Okay, so step 1, I'm going to do it algebraically, I think, first, and then I'll show you how to do it graphically as well. So algebraically speaking, we're going to divide both sides by 80, and I'm probably going to turn that into a fraction as well. So 4.5 divided by, actually I'm going to show you how I'm going to do this on the calculator. So I want that to be a fraction, because I see this 1/2 here, so I'm guessing that might be a thing. So I'm going to take 4.5 divided by 80. That's going to give me a decimal, but it's not a repeating decimal. So I can go to math, and I want it in a fraction. So 9/160. So I'm thinking to myself right now, can I make 9/160 equal 1/2 to the power of x? No, not easily. So if I were to finish this algebraically, I would have to use the definition of log, and then change the log of the base, and then so on and so forth. So that's exactly like the last problem. So instead of doing that, we will finish this problem graphically, since they said that we can do that as well. So graphically, we're just going to type in the right side of the equation. So our y is going to be equal to 80 times 1/2. If you typed in 0.5 here, that's fine. Doesn't matter that much. That x is wrong. That x needs to be as an exponent. Okay, so I've got my y equals. And then I want to know when that y is, or when that function is going to equal 4.5. So I'm making a separate line that is at y equals 4.5. So before we do this, let's look at our window. It is going to be an exponential decay function. And so it's going to be going down. So I can say that my y max, we could say that at 80. Honestly, we don't even need it that high because we only care about when it equals 4.5. I'm just going to leave my x max at 20 because, again, I just have no idea when it's going to hit. So we'll stick with that, and bam. So if you wanted to, you could zoom in to get a little bit closer, but we're just going to use our calculator to do the work for us. Use the intersect button. So our first curve is the blue curve, second curve is the red curve, and bam. It intersects at 4.15. It says round to the nearest whole number. So x is going to be equal to 4. Solve the equation using a logarithm. Round your answer to the nearest thousandth. Sweet. So it's going to be kind of like the second problem we did, maybe? All right, anyway, so we're going to do some algebra first. We're going to add 6 to both sides. So again, at this point, I'm trying to get the exponent by itself. So that's what I'm doing. So after we add 6 to both sides, we are going to divide both sides by 3. And I'm just going to do all of that into the calculator all at once. 237 plus 6. Oh, shoot. There we go. 237 plus 6. So I'm pushing equals right now because I want it to do that plus first. So if I just typed it all in with no parentheses, it would give me a wrong answer because of order of operations. Don't forget order of operations. So we divide by 3, we get 81. So at this point, our new equation is, thank you calculator, you are dismissed, is 81 equals 2 to the power of x. So, I mean, I already know that 81 is not going to be a factor of 2 without getting into decimals. So it's not really worth trying to get a similar base. So we are again going to use the definition of a logarithm. So we're going to say log base 2 of 81 equals x. Technically, what we're doing is we're taking log base 2 of both sides. So it'd be like log base 2 of that side, log base 2 of that side. But by definition of log base 2 of 2 to the power x is equal to x. So just so you're tracking what's happening. So now that we got this, my calculator can't handle that. Cool, no problem. Because our properties tells us that all of this is equal to common log of 81 over common log of 2, or log base 10, whatever you want to call it. So now we're going to plug that into our calculator. So we got log of 81 divided by log of 2 equals 6.339, and we are rounding to the nearest thousandths, tenths, hundredths, thousandths. So it's going to be 6.3340. 6.340. Isn't it nice they gave you this little check button that you can check your answers? That's cute. Wish we would have had that the first several check on learnings we did. All right. Last but not least. Oh, look. A word problem. The amount of radioactive substance, Y, that is left from an original mass, P, after X days of decaying is found by the decaying equation, Y equals P, blah, 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 blah. How many days will it take for 240 milligrams of radioactive material to decay to 7.5 milligrams? Okay, so our original mass is 240, so let's plug the stuff in that we know. And then we're looking for 7.5. So 7.5 got plugged in here. The original mass got plugged into here, which is 240 milligrams of radioactive. The rest of this was given to us. Oh no, where did my, there it is. Yeah, I'm using cool colors. 9, 9, 8, 6, power of x. How many days will it take for 240 milligrams of radioactive? So we need to solve for x. You've got 3 different methods. You can do it algebraically, you can do it graphically, you can do it with a chart. I don't like the chart method, so I'm not going to do that. You can do it algebraically, you can do it graphically. At this point in your life, it doesn't matter. Now, if the question specifies how you need to solve it, then I will want to see those steps. If it does not, you can basically do what you want. Since I am completely confident that you all can graph this stuff and figure it out, because that's just using technology, I'm going to do some algebra. Because algebra's cool. So we're going to divide both sides by 240, and then that's going to leave me with let's try that again. Was that 7.5? Yeah. 7.5 divided by 240. Is that an easy fraction? Yeah, we'll just leave it all in decimal points. So 0.03125 is equal to 0.9986 to the power of x. So we're going to take the log of both sides. We're going to take the log of log base 0.9986 of both sides. That's going to cancel the right side out. So then we're going to have log of 0.9986 of 0.03125. Don't be afraid of ugly numbers. It's fine. It's fine. Everything's fine. It's all fine. So then we don't like log base 0.9986. So that is the same as saying common log of 0.03125 over common log 0.9986 equals x. And here we go. Moment of truth. Log. Actually, let's clear some of this stuff off. Log of 0.03125 divided by log 0.031, oh shoot, 0.9986. Assuming I enter that in right. So our answer is 2473. I'm just going to write down 0.79 for now. And x is in days. Round your answer to the nearest whole number. So how many days is it going to take? We're going to round up, so it's 0.7. So we're going to say 2,474 days. Bam. And now you have 3 methods to solve exponential equations. Good job. I will see you in class.